So this talk is mainly focused on stream processing evolution, especially Spark streaming. While there are other popular streaming frameworks available, idea was to pick the most popular and share this story. I still remember it was late 2010, early 2011 when I got first introduced to big data. I was learning on the job to deliver a product with some stringent timelines. That time it was mainly using Hadoop, MapReduce and Hive. Little that I knew, it's just a beginning, and in mid 2013 I saw myself working on a complex event processing framework enabled by Storm. It was not an Apache project back then. Storm was built by Backtype and made available to the world by Twitter, and made its way to the Apache Incubator program. In the last decade, data processing frameworks have come a long way, with a revolution brought in especially by stream data processing frameworks. While engineers at Google, Yahoo, and Facebook were building and breaking benchmarks using Bigtable, Hadoop, and Hive, they were mainly focused on crunching more and more data using commodity hardware in a batch fashion. While all this was happening, there were a set of folks at UC Berkeley who were focused on solution for the latency problem caused by such long-running batch jobs. Well, enough of nostalgia. Spark shifted the game from being of just volume to that of volume and speed. In evolution of streaming frameworks, Spark has been at the focal point and has transformed data processing over the last few years. Today's episode will throw some light on the early days of streaming and try to catch up to present. Before we talk about the evolution, let's understand what is stream processing. Stream processing is a programming paradigm defining applications which, when receiving a sequence of data, treat it as a collection of elements or data points, and rather than group and process them together, process each data point by itself. In stream processing, each data point is processed as it arrived and independently from other data points. Unlike batch processing, where data points are usually buffered and processed together in bulk. Therefore, stream processors have become an important building block in the real-time applications. They facilitate event data in real time, allowing a user access in real-time state of the system and its data, rather than periodical snapshots. Stream processing allows data in the pipeline to have much shorter latency compared to batch processing. Stateful stream processing enriches the type of computations that users are able to perform on the stream. For example, aggregating the number of events with certain attributes and counting them over time windows, it is possible to create real-time dashboards of the data in the stream without needing to load the data to a data warehouse. That was just the onset. Things got interesting with stateless and stateful stream processing. In a stateless stream, the way each event is handled is completely independent from the preceding event. Given an event, the stream processor will lead exactly the same way every time, no matter what data arrived beforehand. Whereas stateful stream processing means that the state is shared between events. Therefore, past events can influence the way current events are processed. This state can usually be queried from outside the stream processing system as well. Now, stateless stream processing is easy to scale up, as by definition, events are processed independently. The stream can be processed by multiple identical processors with a simple load balancing between them. When the system needs to process a higher throughput of events, you simply launch more processors. Challenge was felt with stateful stream processing. Stateful stream processing is much more difficult to scale up because you need a different worker to share the state. A simple solution would be to use an external store, such as a database. Another option is to partition the stream. Instead of randomly sending events to a processor, you can send events to a processor according to some attribute of the event. For example, in the sessions use case, one could send all events from the same user to the same processor. This way, each processor can handle its own state, significantly improving the performance in this whole flow. However, using this approach means you now have multiple states instead of one. So querying it from outside becomes more complex. Now that we know the basics of stream processing, let's look at the streaming evaluation. It doesn't cover everything, but I'll try my best to cover everything, for you. So stream processing started with Spark dstream, which was a basic abstraction of Spark for streaming and was an extension of the core Spark APIs and was majorly known as Spark streaming. It stayed around till Spark 1.6, it being the first generation, helped improve on latency. However, it was not easy to determine correctness guarantees around it. especially in handling late or out of order data. Sometime in 2017, if I recall, structured streaming was introduced, which was built upon strong foundations of Spark SQL. This was also the time when streaming ETL with support of handling late and out of order data was made possible. Streaming data made it, structured streaming made it easy to convert periodic batch to a real-time pipeline. Now, between 2017 and early 2022, structured streaming improved the features such as event time aggregation, watermarking, stream-to-stream joins, low latency continuous processing mode, and recently, structured streaming has been updated with improved observability and improved stateful stream processing. We may make a deep dive on the recent concepts in the future episode. In this episode, we took a plunge in the past and got to know how we actually got here where we are today when it comes to stream processing, especially Spark streaming. With this, I come to the end of this talk. Feel free to reach out to me through your comments. I'm eager to learn from your experience. My intent is basically to simplify the concepts and bring them to you. If this helped you build some understanding, then I think it's a good idea to like the video, subscribe to the channel, and share it on LinkedIn or where your peer group is. Until we meet next time, keep the beat flowing.